Hello everyone. In this video, we will solve a question based on the influence line diagram for the 5-point loads on a simply supported beam. And we have to find the maximum bending moment, position and its magnitude. So let's solve it. So there are 5-point loads that are 10 kilonewton, 12 kilonewton, 12 kilonewton, 16 kilonewton and 20 kilonewton, spaced equally at a distance of 5 meter over a simply supported beam of span 80 meter from left to right with a 20 kilonewton load leading. Calculate the position and magnitude of maximum bending moment which may occur anywhere in the beam. So if we gather the data, given data, so there are 5-point loads that are 10 kilonewton, 12, 12, 16, 20 and they are equally spaced. So at a distance of 5 meter. So now we can draw the diagram. So let's say this is a we have 5-point loads. First is 10 kilonewton, then 12 kilonewton, 12 kilonewton, 16 kilonewton and 20 kilonewton, and they are spaced equally at a 5 meter interval. So our first step is to find the position of the resultant of the loads. So location of resultant is found using Varignon's theorem. Now total loading is basically 10 plus 10 plus 12 plus 12 plus 16 plus 20 and it will be equal to 70 kilonewton. So our total loading is 70 kilonewton and we have to find the position of this total loading, that is x dash. Now using Varignon's theorem, r into x dash is equal to, so just like we found the moments, we equate the moments, in the same way we will do it. So 10 into 0 and then there is a eccentricity of 5 meter, so 12 into 5 and then eccentricity of 10 meter for the 12 kilonewton load, that is 12 into 10 and then 16 into 15 and then 20 into 20. So we will find the x dash and the value will be 11.71 meter from the point E. So x dash is 11.17 meter. Now since 12 kilonewton load is nearer to the resultant, now we have to check something. Check is like this. This is our resultant force which is very much closer to the 12 kilonewton load. It is around distance 1.17 and this will be 5 minus 1.17, that is 5 minus 1.17 and it will be 3.83 something, where we have 16 kilonewton load. Now there are two possibilities. One possibility is that we find the maximum bending moment at under the 12 kilonewton load, and other possibility is that we find the bending moment at 16 kilonewton load, because 16 kilonewton load is greater than the 12 kilonewton load. So we have to check both the possibility and then answer our question. So here first is that since 12 kilonewton load is nearer to the resultant, but greater load 16 kilonewton is slightly away from the resultant. So we have to check both the possibilities. So our first possibility, so bending moment under 12 kilonewton load. So what we will do, we will keep the 12 kilonewton and resultant at an equal distance from the center of the beam. So this line is very important. What we do, so we have one simply supported beam and this is the center of the beam, and we have a line of point loads. We have find the position of the resultant of line of point loads. So what we do, this is the resultant and this is 12 kilonewton load, and here it will be 12 and then again there will be 10 and here it will be 16 and here it will be 20. So what we do, we will place our loading in such a way that the 12 kilonewton load and the resultant load are equidistant from the center of the beam. So this distance is 1.17. So we will keep our loading in such a way that it will be 1.17 by 2 and it will be 1.17 by 2. So the same is depicted in the figure. So this is the simply supported beam AB having supports at A and B, and C is the center of the simply supported beam. So now our first possibility is that we are thinking that 12 kilo we will get the bending moment at under 12 kilonewton load. So for that we are keeping 12 kilonewton and resultant at equal distance from the center of the beam. So 1.17 by 2 and 1.71 by 2. We place our loading in such a way. Now we will find each distance. This distance, this distance, this distance. Similarly from here, this distance and this distance. So according to the ILD, we will, for the simply supported beam, we will get this type of ILD. And we have, and the maximum bending moment we will get under the 12 kilonewton load. Now we will find all these eccentric distances and then use the theory of similar triangles to find the maximum bending moment. Now, so we know that they are equally spaced. This will be 5, this will be 5, this will be 5, and this will be 5. And total span of simply supported beam is 80 meter. So AC distance is 40 meter and BC distance is 40 meter. So in similar way we will find all the distance. Like if I have to find the distance for this 12 kilonewton load, then it will be what? 40 minus 1.71 by 2. So it will come approximately around 39.15. So this is our point A distance. A is 39.15 and B will be 80 minus 39.15, that is 40.85. Now in the similar way we will find all the distance. It will be 29.15, 34.15, 39.15. This is 40.85, 35.85 and 30.85. And on the basis of this we can find the ordinates. Now how we will find the ordinates? So we know that the maximum bending moment here it will be AB by L. A is this, B is this. So using this we can find this. Once we find this, we can use the similar triangle to find this value, this value, this value and this value. And then we can add all this value. Now AB by L is 39.15 into 40.85 divided by 80. So it will be 19.99. So ordinate at 39.15 is 19.99. Ordinate at 34.15 will be 19.99 divided by 39.15 into 34.5. It will be multiplication. So here we will find this value as 17.43. So bending moment under 12 kilonewton load will be, so basically we get this. This value is, so under 10 kilonewton load the value was 14.88. Then under 12 kilonewton load the value was 17.43, and again for 12 kilonewton load the value was 19.99, and then for this it will be 17.54 for 16 kilonewton, and for 20 kilonewton it was 15.09. So what we will do, 10 into this, 12 into this, addition, 12 into this, addition, 16 into this, addition, 20 into this, addition, and this will give us the bending moment under 12 kilonewton load. So 10 into 14.88 plus 12 into 17.53, 43 plus 12 into 19.99 plus 16 into 17.54 plus 20 into 15.09, and this value is 1180.28 kilonewton meter. Now this is from our possibility 1. Now possibility 2 is that we get maximum bending moment under the 16 kilonewton point load because it is slightly larger than 12 kilonewton load. So bending moment under 16 kilonewton load, keeping the 16 kilonewton load and resultant at equal distance from the center. Now what we will do? The similar process. This is our simply supported beam and this is the center. Now our resultant is this and this is the 16 kilonewton load, and we will place our loading in such a way that the center of the beam, resultant, and this 16 kilonewton load are equidistant. So this distance was around 3.83 by 2 something. So we will divide them and solve. So in similar way we can find the value for this, and on solving this the bending moment under 16 kilonewton load is 1186.7. so it is slightly larger. So the maximum bending moment occur at a distance 41.65 from the left support, and magnitude of the maximum bending moment is 1186.7. But here the problem is this, that this value is actually wrong. This will not be 3.29, but this value will be 5 minus 1.17, that is 3.83. So we will divide in such a way, this is the center of the beam and this will be the resultant, and this is 16 kilonewton load, and this value will be 3.83 by 2 and this value will be 3.83 by 2. From this we will place our loading and then we will solve. So we can solve this for the second possibility. So second possibility will be in such a way, these are loading, this is 10, then 12, then again 12, then 16, and then 20. So this is our resultant. This distance is 1.17 and this distance is 3.83. Now we will place our loading in such a way so this will be the 16 kilonewton load, and then here we will find our loading, that is 12 kilonewton, and it will be then again 12 and then 10. So this value, these are the ordinates that we have to find out, and this is 20. So we have to find out these ordinates, but for that this is our simply supported beam, this is the center, so our resultant will be here and 16 kilonewton load will be here, and this will be 3.83 by 2, 3.83 by 2, that is 1.915, and this will be 1.915. So here now I can solve. This will be the center of the beam, this is the 16 kilonewton load which is at 1.915, this distance is 1.915. Now this distance is 1.915 and this will be 3.085, this is 5 and this will be 5 and this will be 5. So now this is 40 meter and this is 40 meter. Now I can find A value. So A value will be this 41.915 and B value will be 38.085. So now A, B by L, it will be 41.915, 38.085 by L, that is 80, and it will be 19.954. So this ordinate will be 19 point, sorry, this will be 19.954. Now x distances, so this is 40 and this is 1.40 minus 1.915 minus 5, this, so we will get this distance, it will be 33. So this will be 33.085. Similarly, we can find this distance also. It will be 40 minus 1.915 and it will be 38.085. Now for the left hand side, so this is 40, so 40 minus 3.085 minus 5 minus 5. So we will, so this distance will be 26.915. Now this distance, it will be 40 minus 3.085 minus 5. So it will be 31.915 and again for this it will be 40 minus 3.085. So it will be 36.915. Now we can find the remaining ordinates. So for 10 kilonewton load, and we will compare it with the 16 kilonewton load. So 19.954 divided by 41.915 and multiply 26.915. So this will be 12.813. Similarly, next 19.954 divided by 41.915 and multiply 31.915 for 12 kilonewton load, and it will be 15.193. Next 19.954 divided by 41.915 multiply 36.915. So it will be 17.574. Now for 20 kilonewton load, so what we will do, 19.954 divided by 38.085 and then multiply 33.085. So it is 17.334. Now bending moment at 16 kilonewton will be 10 into 12.813 plus 12 into 15.9193 plus 12 into 17.574 plus 16 into 19.954 plus 20 into 17.334. So bending moment will be, so it is 1187.278 kilonewton meter. So we are getting something 1187.28 kilonewton meter, which is greater than bending moment at 12 kilonewton load.